Thousands of fossil fuel plants from around the world released 37.12 billion tons of CO2 emission into the atmosphere in 2021, further accelerating the devastating climate crisis.
Another unforeseen consequence of the pollution released from fossil fuel plants is its impact on indoor air quality. Air pollutants concentrate in crowded indoor spaces like schools, and according to the U.S. EPA, a shocking 50% of U.S. schools have poor air quality. Poor indoor air quality has been shown to negatively impact the health and academic performance of millions of students globally.
Regarding physical health, poor indoor air quality causes headaches and irritates the eyes, nose, and throat. It also harms the cardiovascular system and aggravates respiratory conditions.
Long-term exposure to poor air quality alters the brain, resulting in increased risks of anxiety and depression. Children who are still in development are particularly susceptible to these negative consequences of poor air quality.
Poor air quality also correlates with increased absenteeism and dropout rates. Poor air quality also reduces academic performance, further indicating its impact on the brain.
Our solution, Algae Air, is a small-scale, fully automated spirulina microalgae photobioreactor. Algae naturally feed on air pollutants and convert them into oxygen, improving air quality. Algae, when used in conjunction with an AI-powered bioreactor like we're developing, is 400 times more efficient than trees in removing carbon dioxide from the air because the entire organism is photosynthetic. Our device uses sensors and electronics to maintain optimal algae growth in air purifying conditions, such as an air bubbler to circulate air throughout the algae, ensuring all of it, not just the top layer, is absorbing air pollution. Our device also has an accompanying app displaying algae health and notifying users when they should perform device maintenance. Device maintenance includes harvesting some of the algae using our device's user-friendly spigot system to ensure the algae remains in the load phase so that it continues converting air pollutants into more oxygen and algae biomass, instead of becoming stagnant. This algae biomass can be very useful. For example, you can use it to create eco-friendly biodegradable plastics. Also, users will need to refill the device's nutrient tank with nutrient solution containing ingredients necessary for algae growth tri-annually.
Our device's unique value proposition overcomes issues with traditional air purifiers, such as electronic air purifiers releasing dangerous ozone, and HVAC systems requiring rooms to be on the exterior of buildings to be effective and costing $7,000 on average to implement. Our device is also environmentally friendly through actively absorbing air pollutants rather than simply transferring them outdoors like HVAC systems. There are currently air filters that incorporate algae but do not use technology to maximize the effectiveness of algae air cleaning, resulting in greatly reduced benefits.
We plan to conduct initial device testing and implementation within our school, making other schools the ideal place to market first. Eventually, we will expand to the indoor workplaces such as offices and finally the complete air purification market, including homes and hotels. Our goal is with our device's unique value proposition to gain a 10% market share. These figures show our potential revenue with a 10% market share. Our serviceable obtainable market is certainly large enough to initially sustain our venture, especially if we expand to a global market.
Our algae air units will retail at $220 with a 73% profit margin. Also, users must purchase nutrient solution refills for their device, which will be needed tri-annually. Each nutrient refill will retail for $15 with an 87% profit margin.
For customer validation, we surveyed 100 students and 20 teachers. 95% of students said they were concerned about our school's poor air quality and how it is impacting their health. 100% of the teachers would use our device if the district provided it to them, and 75% would purchase the device themselves to use in their classrooms.
We will become a certified B Corporation, a business that balances profit with purpose by meeting the highest standards of social and environmental performance, public transparency, and legal accountability. Strong business ethics helps companies grow, ensuring a strong triple bottom line. Additionally, many investors and consumers consider ethical business practices in investment and purchasing decisions, increasing our investments and profit.
To help less fortunate Title I schools that cannot afford our Algae Air device, we will donate one for every 10 we sell. Currently, we are in the development stage of our process and plan to start our revenue model next year. Looking at our predictions, you can see exponential growth over the next 3 years.
So far, we have received $7,500 in funding from the Massachusetts Institute of Technology to develop our innovation and are working with a pro bono lawyer to patent our device. We are presenting our fully functional prototype to MIT professors and potential investors later this month.
Now let's take a look at our team. I'm Jensen, Chief Technical Officer. I've done robotics for 8 years, and last year created my own custom localization coding library that brought my robotics team to the World Finals.
Hi, I'm Aaron. I'm the Chief Sustainability Officer. I've always loved helping the environment through engineering, and I even co-founded a nonprofit called Seeds of Hope.
Hi, I'm Denise. I'm the Chief Financial Officer, and I founded my school's Hispanic Student Association and run its finances, which includes organizing fundraisers.
Choose Algae Air to improve air quality alongside the health of our world.